Beneath today's North Sea lies a lost world. It is not myth, not legend, not a British Atlantis. It is called Doggerland. Around 7000 BCE, Britain was not an island. From what is now the northern Netherlands, Belgium, and northwest Germany, all the way to the east coast of England, there stretched a vast lowland plain. Its area was comparable to a quarter of modern Europe's landmass. Rivers wound across it. Forests covered it. Wetlands connected lakes. Deer migrated. Mammoths passed through. Humans walked its open ground. It was land you could cross on foot. Its name comes from the 17th century Dutch fishing vessels known as doggers. Doggerbank, the shallow ridge that still exists today, is the remnant of that vanished high ground. Now it lies in silence beneath the surface, a shoal hidden under the sea. The first signal that something was there did not come from scholars, but from fishermen. In 1931, the trawler multiplied by was working about 40 kilometers off the Norfolk coast, at Ower Bank. What came up in the nets was not only fish. There was a large block of peat, and embedded within it, a barbed bone spear point. The barbs were clear. The tool marks unmistakable. It was not formed by nature. Someone had shaped it. Someone had used it. The seabed had once been dry land. The discovery was startling, but at the time there was no broader framework to interpret it. It was recorded and then largely forgotten. Doggerland was not systematically confirmed by a single dramatic discovery. It emerged through industrial accident. In the mid-20th century, oil and gas exploration began in the North Sea. Companies used three-dimensional seismic reflection technology to map underground structures. Shock waves penetrated the seabed, and their return times were converted into subsurface images. The goal was oil. But geophysicists noticed anomalies. Certain structures did not resemble marine sediment. They looked like river valleys, clear incised channels, branching tributaries, meandering curves. Not wave marks. River systems. Between 2003 and 2007, a team led by Vince Gaffney and Ken Thompson at the University of Birmingham obtained large volumes of commercial seismic data from petroleum geoservices. Using this material, they reconstructed approximately 23,000 square kilometers of early Holocene landscape. It was a map no one had ever seen. The rivers were named. One became the Shotton River. A dune system was called the Spines. The high ground was Doggerbank. Between sandbanks lay the basin known as the Outer Silver Pit. A lost geography had regained its place names. Seismic data were not the only evidence. In the 1980s, the British Geological Survey systematically catalogued North Sea core samples. In the Doggerbank region, they identified peat layers and freshwater sediment structures. Peat forms only in terrestrial wetlands. It requires plant accumulation, low oxygen, and time. It cannot form in deep marine environments. That meant wetlands once existed there. Pollen analysis added detail: birch, pine, hazel. The sequence recorded the transition from late glacial tundra to temperate mixed forest. In 2020, researchers at the University of Warwick extracted ancient DNA from sediments, sedaDNA. Because DNA degraded over thousands of years in marine contexts, new authentication methods were developed. One innovation was biogenomic mass analysis. Scientists observed that at the moment the Storegga tsunami reached the region, DNA from large woody plants surged abruptly in the sediment record. Trees swept into the sea were encoded into the strata. Sedimentology, palynology, geophysics, paleogenomics, four independent lines of evidence converged over the same submerged plain. Doggerland was no longer speculation. It became a reconstructible paleolandscape system. Meanwhile, fishing trawlers continued to bring up artifacts: flint tools, worked antler implements, bones of large terrestrial animals, mammoth, rhinoceros, hyena, cave bear. Before 2024, more than 2,000 objects had been recovered from the area, nearly 1,000 of them barbed bone spear points. The smallest measured around 9 centimeters. The largest approached javelin length. In 2020, researchers at Leiden University analyzed 10 such weapons. 8 were made from red deer bone or antler. 2 were made from human bone. "We expected deer," said Johannes Dekker, then a master's student leading the study. "But human bone? Not even in my wildest dreams." These spear points bore clear high-velocity impact traces. They had been thrown. They had struck something. Hunting or something else. We do not know. But we know people were there. They made these tools. They used them. They left their traces beneath today's sea. A fragment of Neanderthal skull, dredged 16 kilometers offshore near Middledeep in Zeeland province, dates back more than 40,000 years. Even before the Mesolithic, earlier humans had crossed this land. In 1998, Bryony Coles, professor of prehistoric archaeology at the University of Exeter, published a paper in Multiplied by Antiquity Multiplied by titled Doggerland, a speculative survey. Until then, the region had often been dismissed as merely a land bridge, a corridor, not a home. Coles reframed the question: do not treat the land as a passage. Treat it as a homeland. That shift in perspective marked a turning point. The North Sea Paleolandscapes project used three-dimensional seismic data to map ancient river networks. Research revealed that what are now the Seine, Thames, Meuse, Scheldt, and Rhine once extended eastward, converging into a common trunk river that crossed the Doggerland plain before flowing west into the Atlantic. Britain was not yet an island. All those rivers were one system. Now consider sea level itself. During the early Holocene, sea level rise was not uniform. Melting ice sheets released vast quantities of fresh water, but the rate fluctuated in phases. Around 10,000 BCE, sea level began rising significantly. By about 9,000 BCE, a broad tidal bay had formed between eastern England and Dogger Bank. Around 8,200 BCE, abrupt climate events and glacial lake drainage accelerated the process. Around 6,200 BCE, the Storegga submarine landslide off Norway displaced roughly 290 kilometers of continental shelf, generating a massive tsunami in the North Atlantic. Waves swept across the lowlands of the North Sea. Research published in Multiplied by Geosciences Multiplied by in 2020 indicates that when the tsunami reached Doggerland, it still carried destructive force. For Mesolithic communities caught in its path, the event would have been catastrophic. Yet paleotopographic models suggest some regions may have recovered in the short term, retaining near previous landforms. The tsunami was a shock, not the final end. The true disappearance was gradual. Most models indicate Doggerland was lost through the long interplay of inundation and expanding wetlands. The lowest river valleys flooded first. Marshes spread. Estuaries retreated inland. The land fragmented into islands. Dogger Bank, once high ground, likely remained above sea level until around 5000 BCE before finally submerging. The process unfolded over millennia. In February 2026, researchers at the University of Bradford published new findings based on geochemical signatures from sediment cores in the southern North Sea. Alternating layers of freshwater plant traces, terrestrial soil organics, and marine input signals precisely recorded the rhythm of marine transgression. The chemical evidence shows that sea level rise began around 10,000 years ago. It was not sudden. Not a single catastrophic event. It was a slow transformation that each generation experienced, but no one could perceive in its entirety. When Doggerland functioned as a land bridge, Britain and continental Europe maintained frequent contact. River systems formed ecological corridors. Deer migration routes, fish resources, hazelnut groves, mobility followed continuous bands of abundance. As sea levels rose, continuity was severed. High-yield nodes, estuaries, wetland edges, uplands became focal points of repeated use. At Star Carr in Yorkshire, occupation between roughly 9000 and 8000 BCE left behind Britain's earliest known wooden platform structures. Excavations up to 2015 revealed structured activity zones, preserved organic materials, and 21 red deer antler headdresses bearing cut marks, perforations, and deliberate shaping. Their details resist purely functional explanation. They appear ritual or perhaps identity-related. As the land bridge narrowed, the cost of long-distance interaction increased. Technological transmission pathways contracted. Marriage networks may have shrunk. Connectivity decreased. Internal integration pressures grew. At Lynmurra in Buckinghamshire, 25 large Mesolithic pits, dated between about 8500 and 7700 BCE, were discovered in patterned arrangement. Each required coordinated labor. This predates agriculture, predates permanent settlement. Yet already it signals organization, coordination, and collective intention. Resource concentration leads to periodic gathering. Repeated gathering builds memory. Memory generates meaning. Ritual is not mysticism. It is a coordination mechanism. When people return to the same places again and again, those places accumulate identity. Structure takes root. When Doggerland finally disappeared, Britain became an island. Geographic isolation does not automatically create national identity, but it changes interaction patterns. Overland networks became maritime networks. Frequency shifted. Mode shifted. Social network structures adjusted accordingly. In 2024, researchers from Bradford collected new sediment cores from the North Sea, continuing the search for direct traces of human activity. Vince Gaffney compared the task to searching for the Goldilocks zone of exoplanet.